This is, I think, has to do, I think this is internet connections. I can't remember what that one was, but it looks really pretty. So networks, because of this fixed infrastructure, communications and transport don't, it feels like, because cost is falling, they're getting better, you can go everywhere. But in fact, you still can't go everywhere. It's the same problem that Weber was talking about, where you want to be near a good port, or you want to be on a main railroad line. You still want to be in a place that's well wired for the internet, has really good service, you can have really fast DSL or whatever your connection is, or, if you're on a cell phone net, you know how cell phone networks work. Some of them are more universal than others. So this is a problem that business and consumers run up against all the time. So it affects the location of industry. You want to be, if you're using natural gas to produce plastics, you want to be around these networks. And indeed, most of the plastics are made here, Louisiana and Texas, and up around New Jersey. Now, Oklahoma's kind of weird because they don't have any plant factories out there, but it's a big center for the interchange of pipelines. Historic curiosity goes back to when Oklahoma was a major oil producer. And if these networks don't work, transport doesn't work. And a great example of this is the EU. Now, when you think about Europe, you think about trains that work. When you think about the United States, you think of trains that don't work, like Amtrak. You can't build a high-speed train to save our lives, right? France is knitted together. Germany, Spain now, knitted together by these fantastic high-speed trains. Except they're really good for passengers. But their train system for freight is lousy because the gauges don't even connect between France and Spain. They now got, the trucks, the wheels, they automatically change to the new gauge when they cross the border. That's an improvement. You just have to get off the train, climb on another train. So now it'll go across the border. Whoop-dee. But they still don't have the same gauge. The United States solved that problem 100 years ago. And Europe is still fiddling with it, which is what the EU is for, is to overcome those national differences. But it's by no means done. So the EU moves about half as much stuff with the same output as the US by rail as we do. It moves much more by truck, which is surprisingly inefficient, by the way, because rail is much more efficient for an awful lot of heavy hauling. It doesn't have to be coal, though a lot of it is, but for a lot of goods, like appliances, put them in a train, and a truck is a very inefficient way to do it. Networks tend to have hubs. So transportation systems have nodes, and whatever you want to call them, nodes, hubs, places where these networks cross. Oklahoma Gas Pipeline is a hub. Well, cities are generally the hubs of transport. In the case of Oklahoma, no. But in the case of Chicago, LA, Paris, which is this map here, train lines all run through Paris. This is the port of LA. So these are really important hubs. And transshipment points with intermodal transfer tend to be major hubs. And the Port of LA is a huge hub between seagoing vessels and trains. But what's interesting is they then take the trains up, I'll tell you more about, up to Riverside in Ontario, and that's where they move it to other trains or to trucks. And so that's another hub, and that's why all those warehouses are out in Ontario and Riverside. Anybody here from the Inland Empire? Hey, there we go. Why do you think the Inland Empire grew so big? You just think people like to live in the desert? People love Riverside, it's so beautiful? Well, maybe you think it's beautiful. It has a certain appeal. My niece lives out there, she teaches at Riverside and thinks it's really beautiful. It has its moments. I like certain desert landscapes, they're really beautiful. And I wouldn't say it was quite up there with the Bay Area, but why are those people moving out? Partly it's got cheap housing, but partly it's because the jobs moved out. Tens of thousands of jobs moved out with these warehouses. That's where everybody works. Okay, what else? It's a lumpy geography. Thank you. That's a technical term, lumpy geography, because I don't have a better one. But Paris still dominates all transport in both passenger and freight in France. Very important in the whole European system. Talk I heard last year at the AAG was talking about how many tens of millions of new square feet are being built in the far suburbs of Paris to handle all this traffic as it continues to cement its position as the center of all traffic in the world's fifth largest economy. And I think in next week's lecture I'll tell you about Chicago and LA and what they've done. The same thing with communications. There are nodes, mail transfer stations. Those are diminishing as mail diminishes. Did you ever ride BART and wonder what that huge building is at the West Oakland BART station? There's a gigantic building there with a gigantic parking. That's a package center for the post office. How about that gigantic weird building near the Albany Bulb? That's a post office package center, sorting center. It's where all the stuff goes in, gets sorted by machines and people, and then goes back out. And it gets on bigger trucks, or goes to the airport or whatever. Telephone switching stations used to be a very big part of the urban landscape. Now, because of big switches, now it's all electronic, so it fits in like one corner of these old buildings. Electrical, well, we're not talking about electrical, but the old switching things were very big and took big buildings. But we still have microwave junctions. You see them on roofs, on hilltops, all these little microwave things pointing everywhere. That's a transfer station for the microwave. The satellite is a transfer station for microwave communications, cell networks and internet and so on. Server farms. Oh, I was going to get a good geography. I was going to get a good map of server farms. Server farms, that's like the main nodal geography of communications in our time. And they're just huge, and they're everywhere, and they're growing like crazy. And you don't even know where they are, right? I don't know where they are. Well, I know where a couple are. There's a big one in San Jose and one in San Francisco. But there's like huge ones out in eastern Oregon now, in the middle of nowhere for Amazon or Google or somebody. And unfortunately, nobody maps these because often it's very hard to get the information where they are. They're huge energy users, and they're hugely important to our whole communication network. And one blows up, and which they do occasionally, they go down, and suddenly Google goes, oopsie, we have a problem. Or Amazon, we can't deliver. Today we lost all these orders, we got to get it back up. That's because their server farm went down. The power went out, or the computer started malfunctioning or something. And all a server farm is a big building full of dozens, scores, hundreds of computers transferring, doing the internet transfers and other things. So these are all lumpy networks. The internet is lumpy. Everything's lumpy. And of course, the lumpiest of all, in some ways, is personal communication. So we have this thing where we think because transport and communications are getting better and the costs are going down, that everything should spread out. Remember, I started talking about that before, coming back to this. That there's this idea that, well, everything should spread out. You could locate anywhere. It doesn't matter. And yet people don't. And industry doesn't. People keep coming into cities. The cities are growing as the world population, percentage of world population. And cities are where the action is. What does that mean? It's where you communicate with people, where you see what's happening. It's about personal contact. And funnily enough, we are still incredibly reliant on face-to-face contact, despite all the stuff about video where's the video conferencing that everybody's supposed to be doing? They are doing more now because with rising fuel prices, airline tickets for their executives, a lot of big companies are trying not to do that because a lot of it was unnecessary. But I'll tell you, the big deals are not made over video conference. They are made in the same room, you shake hands, you look them in the eye, you have a drink, you go play golf, or whatever guys do. It's mostly guys. In case you haven't noticed, aren't too many female CEOs, but it's less than 10%, 10, 12%. So I use guys advisedly. Although guys is becoming a more and more neutral word, right? Okay, transport hubs, major junctions, old port cities, old railway cities, today's port rail, highway hubs, airport city, yada, yada, yada. So, things like San Francisco Airport, LAX, and so on are huge hubs, and they have huge amounts of business around them, both so that business people can jump on the plane and so that products can go in and out, the lightweight, high-tech products go in and out by air. Oh, here it is. I do have this here. Okay, Chicago is the rail hub of the Midwest. It's still number one in railway traffic. It started out by linking the Midwest to the east via the Great Lakes and the Erie Canal, but it's built itself up more and more and more as the railway hub. But it's been the railway hub of America since the 1850s. That's a pretty good run. And they just built a huge new project, billions of dollars, to cement this role. I guess that's some railway yards in the old days. Must be in Chicago, because there's no 40th Street yards in San Francisco. San Francisco used to be the hub of the Pacific in the old days, for my urban geography people. It was the number one port. It had the Southern Pacific, and the Bay Area was the hub of the whole western United States and well beyond, until through basically World War II. No longer. Now it's LA. So I think I have LA. Okay, Chicago, keeping on top. Yeah, in the 1860s, they built the stockyards. They built a Beltway Railway in Chicago to help cement their place as the leading hub of the rails in the Midwest. In the 90s, they're still doing the same thing. 6 railways and the Illinois Department of Transportation work together, billions of dollars to try and get, so they have no grade crossings. So there's no place you have to stop. Cars have to stop while the trains go by. They go boom, boom, boom. They all connect up together. You can do intermodal transfers very easily, and it was billions of dollars. San Francisco did a similar thing around 1900, but then fizzled out in the days of the container revolution, which I'll come to. Okay, LA just put in, I guess it's the next slide. This is a great map showing global traffic out of LA. LA is the main place that all the China trade comes into. And then it goes out across to Chicago, across the east, across the Midwest, the South, the East, and even up here, up to the north. So LA is this unbelievable hub with the largest quantity of containers, one of the four or five biggest container ports in the world. It was briefly number one, but then the China ones all got bigger. So yes. Oh yeah, much bigger. Oakland's about number 6 in the U.S. now and about number 25 in the world. It's not insignificant. It's still a big port. But it's hinterland. It's basically taking commodities in and out of an area about like this, whereas L.A. is just shipping stuff all over the country. It's a day closer to the Panama Canal, and it's a day closer to southern China. Or it's certainly closer. Maybe it's a day. No. But it's definitely closer. Plus, the rail connections are much better because they're flatter. We have these ridiculous railroad that goes over the Sierra Nevada. And the only reason it's there because of the Civil War. They didn't want, when they planned it in the 1850s and 60s, the Northerners didn't want it to go through the South. They wanted to go across here and join up the Union and not go down where the Confederacy could grab it. But actually, the L.A. route is a much better route. Yeah, and in the 90s, they put in, and early 2000s, they did this massive Alameda Corridor project. Anybody from LA, you might know about this, where they ran this sunken rail line, below grade, so traffic doesn't interfere with, all the way from the port up to downtown. Then you hit the main railroads, there's 2, Burlington Northern and Union Pacific, go out of there and head east over towards Riverside, Ontario, and then do all that transferring stuff. They probably want to continue this all the way out to Riverside. It's a huge investment, billions, in which the state, by the way, state and local government, SCAG, and all paid for. And the feds, too. The feds pump a lot of money. And here's my thing on the Inland Empire, but I've already blabbed about this. But that's a picture I took sometime flying in Ontario. 200 million square feet out there. It's really phenomenal. That's a lot. The Bank of America building in San Francisco is like 1.25 million square feet. So it's like 200 Bank of America buildings on their side. And transport revolutions. To wrap up here, transport and communications have, since the Industrial Revolution and even before, been revolutionized continuously, repeatedly. Not continuously always, but repeatedly. In the 1820s, the revolution was the canal system, the Erie Canal. The Erie Canal connects the Great Lakes to the East Coast. Phenomenal development in cheap transportation in an era when you had to take things by wagon and horseback. And it was so much cheaper to drag a boat along a flat canal. And the canals went all over the eastern Midwest. The railroad in the 1850s and the telegraph is huge. I mean, this is the first time people could send messages that weren't physically carried. Suddenly you had electronic messaging or electrical messaging. You had to know Morse code and all that stuff, but it's a phenomenal change in the speed of news, like the news of Lincoln's assassination reaching San Francisco, by telegraph, very, very fast. So that just blew people's minds in a way that it's hard for us to imagine because we're so used to speed. Of course, the internet does blow our minds in a lot of ways, but that kind of speed was just unprecedented. Trucks and aircraft. Think of aircraft. The ability to move masses of people around in hours around the world instead of days and weeks. And these tremendous revolutions, again and again and again. And it transformed the landscape of the world we live in. Stuff moves around more. The nation was more united. The building of a national economy, trading all over the country, breaking down old regionalisms and so on. And, we used to read Gary Field's Territory of Profits in this book, which was really helpful about transforming the geography of industry. But he makes an argument that it's really like the transport communications revolution sort of drive industrial location and industrial change. That's not quite fair because they're very, very closely related. You can't have railroads without the ability to build very solid boilers that don't blow up. Remember the early steamships? Steamboats used to blow up all the time? The 1850s, you had very, very strong boilers who could take the pressure of a railroad engine. What about the pistons? How do you make the precision of a piston? You can't do that before 1850. How about the rails, casting miles and miles of steel rail? How about cutting the ties? You can't do that until you invent the circular saw in the 1830s that can spin and cut timber at an unbelievable rate they never could before. And so on and so on and so on. So transport and industry develop together. The transport improves things for industry, moves goods faster in largest markets, and similarly, industry, it's like with research and technology. Industry feeds back into laboratories. Well, it certainly feeds back into communications. So you can't have the internet without the little switches and the optical cables. And you can't do that until laser technology in the industry that can produce that spun glass fiber improves, or until electronics can miniaturize these very powerful switches, or the servers, which are no longer fill rooms to calculate pi. They can do these amazing things with a little computer that doesn't look any bigger than a box. I'm going to finish on the container revolution because it's kind of interesting. If you want to talk about globalization, and that's why I want to finish up here, coming back to globalization, you can't have globalization without transportation, communications, revolution. And the key elements here are the container revolution and long-distance communications by satellite and internet. The container is invented in the 1950s in New York, and it starts to take off as a major mode by the 1960s. Oakland, actually, interestingly enough, is one of the first ports to put in containerization, and that's why Oakland takes off, becomes the world's biggest container port for about 10 years, and just kills San Francisco. And then LA and everybody else scrambles to try and get container. San Francisco never really does, so they're out of the picture. Again, it totally dominates the shipping of goods today. There's still tanker shipping of oil and gas, but I'm talking about hard goods. They pile them up on a ship with a crane, and here's the kind of growth curve. Really phenomenal growth of these things. And the advantage of a container is not only that they're easy to load on a ship, because you don't have to get longshoremen by the hundred to figure out how to put these things on pallets, pack the pallets in the hold of the ship. It's a very dicey process. No, you pack them at the factory, pack them full, say, deliver to Walmart. Off it goes. And never, no hands touch it until it gets to the Walmart warehouse. And it goes on a ship, and then on a train, and then on a truck, and it finally gets to the Walmart warehouse in Arkansas, and it's never been touched. That's really cheap. That keeps your labor costs down. And it's really secure. So, rain isn't supposed to get into these things. You don't get theft. Very important. And it's very cheap to move them around by crane. Very little labor. And you can move them from train to boat to truck. Just pick them up, move them on to the next mode. That hugely simplifies this historic problem which created port cities, which is transshipment. So simplified. It's not gone, which is why we still have cross-docking, but it's still simpler. And it completely wipes out old ports like San Francisco. A couple pictures of old San Francisco there. The whole port system of the world is transformed. Ships have been transformed, bigger, deeper, and also built in new places. Korea and Japan mostly. Trains have picked up their traffic, are now really important again. Vast, huge increases in traffic for trains since 1980 or so with containerization. And this is the backbone of globalization. Plus, you need big firms, you need logistical management. We'll talk about that next time. Okay.